In our last journey on Infinity Beyond, we imagined Earth not as the lush blue marble we know today, but as a frozen orb, a snowball Earth. Entire oceans locked beneath ice, continents smothered in snow, and the sun's light reflecting coldly off vast glacial landscapes. But now, a question emerges from the frost. How did life survive this cataclysm? To answer that, we need to look beneath the surface, quite literally. Despite Earth being encased in thick ice sheets, especially near the equator where temperatures were typically warm, scientists believe there were pockets of warmth that provided refuge. The ocean floors, for instance, tell a very different story than the icy ceilings above. Near hydrothermal vents, cracks in Earth's crust where heat and chemicals spew out from the mantle, conditions were surprisingly stable. These vents created a warm, mineral-rich environment where early microbial life could not only survive, but thrive. These life forms didn't need sunlight. They relied on chemosynthesis, the ability to derive energy from chemicals like hydrogen sulfide rather than solar photons. It's a process still seen in extremophile bacteria today, thriving in places like the Mariana Trench or deep-sea volcanic rifts. It's remarkable to think that while the surface froze in silence, life below danced with chemical fire. But that's not the only refuge. There may have been polynyas, open water regions surrounded by sea ice, similar to those found in polar regions today. These areas, possibly kept open by ocean currents, winds, or geothermal activity, could have served as life-sustaining oases, allowing light to penetrate, gas exchange to occur, and photosynthesis to continue. Primitive algae and cyanobacteria might have hovered just below the surface, absorbing the faint winter sun and continuing the ancient biological rhythms. Scientists have also proposed the existence of thin equatorial belts, where ice cover was less extreme, especially in early stages of the glaciation. Though brief and sporadic, these bands of open or slushy water could have been vital escape routes for certain species. Even sedimentary rock records from these periods show glacial dropstones, chunks of rock carried by icebergs and dropped into sediments in what would have been tropical waters. Their presence hints at both icebergs and liquid water coexisting near the equator, a tantalizing sign of instability in the snowball's grip. And yet, even in total darkness, life had tricks up its sleeve. Some microorganisms enter a dormant state, forming spores that can survive in extreme conditions for hundreds or even thousands of years. Others evolve protective shells or antifreeze proteins to cope with sub-zero temperatures. Evolution is often forged in adversity, and here, in one of Earth's harshest climates, it may have honed life into forms both resilient and astonishing. This resilience opens the door to speculation far beyond Earth. If life could survive under kilometers of ice without sunlight, drawing energy from the crust, what does that say about places like Europa, the icy moon of Jupiter? Or Enceladus, Saturn's moon that sprays water from its subsurface ocean into space? Or even exoplanets orbiting dim red dwarfs, permanently locked in glacial twilight? Snowball Earth becomes more than just an Earth story. It becomes a cosmic survival manual. The same strategies life used here might exist elsewhere, hidden beneath alien ice. But let's not forget what came next. Eventually, Earth warmed. Volcanoes, buried beneath the ice, continued to erupt. Over millions of years, carbon dioxide built up in the atmosphere. With little to no weathering processes during the deep freeze to remove it, CO2 levels rose steadily, acting like a planetary greenhouse. Eventually, the ice couldn't hold. Temperatures crept upward, glaciers retreated, and Earth began to breathe again. The transition was not gentle. The melting of vast ice sheets likely triggered super greenhouse conditions. Oceans turned acidic. Weather patterns grew violent. Yet, in this turbulent awakening, life exploded. New ecological niches emerged. Evolution accelerated. Complex, multicellular organisms began to dominate. That long, glacial sleep may have prepared Earth for its next act, one of rich biodiversity and creative adaptation. Let's take a moment to reflect. The idea that life can endure, even when the sky freezes over, when the oceans are buried beneath silence, and when the sun itself seems distant, is profoundly humbling. We often think of fragility when we imagine living things. But life, as Earth shows us, is incredibly stubborn. It persists, it adapts, it hides in the dark and emerges stronger. And now, as we look out into the universe, that persistence gives us hope. In the next segment of our Infinity Beyond journey, we'll uncover the mysteries of how the Snowball Earth hypothesis was discovered, from rocks in Africa to isotopic fingerprints in China, and how Earth's frozen past is helping scientists decode climate change today. Until then, stay curious, stay brave, and remember, even in the coldest corners of the cosmos, the spark of life may still be burning.